So next concept which we are studying is kinetic energy in rotational motion. Okay, ma? So see here, for example, this is a body of mass m and it is moving with a velocity of v. Okay, ma? Then what will be its kinetic energy? So kinetic energy of translation, no ma, this one, what kind of kinetic energy? Translational kinetic energy is half mv square. Clear, no? Kinetic energy because of motion of a body in a straight line. So kinetic energy is equal to half mv square. Clear, no? Similarly, for example, if I take a disk, clear, no? So consider this is a disk rotating about this axis of rotation, okay, with an angular velocity of omega. Angular velocity of this disk is omega. Then its rotational kinetic energy can be written as half I omega square. This is the formula. Clear, no? So half mv square is the kinetic energy of translation and half I omega square is the kinetic energy of rotation. Okay. Now similarly, if I consider that this is a disk, okay. Now see ma, here this disk is rotating about center of mass only, no? This is the center of mass of the body also, no ma? So therefore you can write moment of inertia about a center of mass multiplied by omega square. You can do like this also. Similarly, if a body is rotating about this axis, are you able to understand, ma? With an angular velocity of omega. Similarly, it is a translating also. It is moving in a straight line also. Are you able to understand? It means this motion is a combination of translational motion as well as rotational motion. Then this body will have two kinetic energies. No? Kinetic energy because of moving in a straight line also will be there. Similarly, kinetic energy because of rotation also will be present. Okay. So therefore, what is the total kinetic energy? So total kinetic energy, how can I write? I can write it is half I center of mass into omega square plus half m v square. So I can write like this also. Are you able to understand, ma? So half I center of mass into omega square, this is what? This is kinetic energy because of rotation. Clear, ma? And this is the kinetic energy because of translation. So body will have both kinetic energies. Are you able to understand? So half I center of mass into omega square plus half mv square. Are you able to understand, ma? So this is how I can calculate the total kinetic energy of a body. Understood, ma? Make a note up to here. Clear, ma? Similarly, now let us see the same body, ma. For example, let us take a condition of rolling condition. Rolling. Okay, ma? What is meant by rolling we will study later. First of all, here let us see. Listen, ma, first of all, then you can write down. See, ma, consider this is a disc, this is a sphere, this is a hollow sphere, anything. Are you able to understand? Consider a ring. Now see here, when body is rolling, what is meant by rolling? Rolling means the point which is in contact with the ground, this point. Are you able to understand, ma? The point which is in contact with this ground or the road on which this body is rolling, this point will be temporarily in rest position. Okay, ma? You should have seen rolling tires, no? So the point which is in contact with the ground, that point will be temporarily in rest position. టైర్లు రోడ్డు పైన రోల్ అవుతున్నాయి, స్లైడ్ అవ్వటం లేదు కదా. దే ఆర్ నాట్ స్లైడింగ్, దే ఆర్ రోలింగ్. సో వాట్ ఈస్ మెంట్ బై రోలింగ్? దిస్ పాయింట్ విచ్ ఈస్ ఇన్ కాంటాక్ట్ విత్ గ్రౌండ్, దట్ విల్ బీ టెంపరర్లీ ఇన్ రెస్ట్ పొజిషన్. సో ఇఫ్ ఐ టేక్ వెలాసిటీ ఆఫ్ దిస్ పాయింట్ p, then velocity of point p is 0. Okay, ma? But other parts of the tire, definitely it will be having some tangential velocity. But tangential velocity of this point will be how much? 0. That condition is called as rolling condition. Are you able to understand, ma? Now if you take the condition of rolling, so here I will write down. So what is the condition of rolling, ma? Rolling means the point of wheel in contact with the ground, okay, ma, is temporarily at rest position. Okay, ma? It is temporarily at rest position, this point. Other points, they have tangential speed. Okay, ma? For example, if you take this point A, this point A will have tangential speed in this direction, which I can call it as VTA. This point will have tangential speed in this direction. This is point B, which I can call it as VTB. Are you able to understand? But at this point, it will not have any tangential speed. It will be temporarily in rest position. That condition is called as rolling. Okay. So you should have seen a tires rolling on the ground, Nama. The point of the tire which is in contact with the ground, is it sliding? No, it is rolling. Road is in rest position, no? So therefore this point of the tire also must be in rest position. That condition is called as rolling condition. Are you able to understand, ma? Okay. Now in the case of rolling, can you say how can I calculate its total kinetic energy of this wheel, ma? Total kinetic energy of the wheel is how much? Can you say? Chappandi. So let us consider it is having an angular velocity of omega, and its velocity of center of mass is how much? Vcm. Velocity of center of mass is Vcm. Are you able to understand? Now can you say what is its total kinetic energy? How can I calculate? Total kinetic energy is how much? Come on. How many kinetic energies it has? వినటం లేదు సరిగా, ఒకసారి వింటే మళ్ళీ మర్చిపోకూడదు, అలా వినాలి. హౌ మెనీ కైనెటిక్ ఎనర్జీస్ ఇట్ హ్యాస్? 2 kinetic energies. What are they? Kinetic energy because of motion in a straight line. This wheel, it is moving in a straight line, no? So it will have which kinetic energy? It will have kinetic energy because of translation. Translational kinetic energy it will have. Similarly, one more kinetic energy. Kinetic energy because of rotation also it will have, Nama. Both kinetic energies it will have. Okay. So what is the kinetic energy because of translation? Kinetic energy because of translation is half mv center of mass square. That's all, no? Kinetic energy because of rotation? So half I center of mass multiplied by omega square. Okay, ma? Now here what is meant by I center of mass? I center of mass means what? I means moment of inertia. Moment of inertia about which point? Moment of inertia about the center of mass. Clear, no, ma? Because already we studied that moment of inertia depends on axis of rotation, no? Are you able to understand, ma? About which axis we are taking moment of inertia? We are taking moment of inertia about this point, about center of mass. Ee wheel ki center of mass ikkade kada untundi. So around that center of mass, moment of inertia is ICM. Clear, ma? So therefore what is this one? Moment of inertia about what? About the center of mass. Are you able to understand, ma? Up to here it is clear, no? Okay. Now see, ma, in the case of rolling, temporarily I can consider that this total body is rotating about this axis. Okay. Now this body is rolling. Rolling means what? It has a translational motion also, motion in a straight line also. Similarly it has rotational motion also. Rendu motions unnai kada. It is moving in a straight line and it is rotating also. But when the body is rolling, okay. So see, ma, so therefore what is the total kinetic energy, ma? Kinetic energy of translation plus kinetic energy of rotation. Now see, ma. See, ma, when body is rolling, listen very carefully. When body is rolling, this point is in rest position, no, ma? Clear, no? So this point you can call it as the temporary axis of rotation. Okay, ma? Now we are considering two motions, no? Body is having translational motion also, body is having rotational. Rendu unnai kada. But if you take this point to be the axis of rotation, then I can consider body has only rotational motion. Are you able to understand, ma? If you take this axis, ide kada rest lo unna point, and axis will be always in rest position, no, ma? So if you take this point to be the axis of rotation, it means if you remove this total rod, okay, ma? Then I can assume that this body is totally rotating about this axis. Then the body does not have translational motion. It has only rotational motion maatrame untundi. Clear, no, ma? So therefore what I say, for example, if this is the rolling body, clear, no, ma? Rolling with an angular velocity of omega, velocity of center of mass is Vcm. Okay, ma? This point I can take it as IAR, or you can call it as instantaneous axis of rotation. Okay, just, or you can call it as instantaneous axis of rotation. Okay, IOR also you can call it as instantaneous axis of rotation. Instantaneous axis of rotation means what? I will assume that temporarily body is rotating about this point. Okay, so it means that if you remove this total rod, what will happen after some time? The body may be rotating like this. Okay, so it is moving around this point. After some time I can assume body is rotating like this. After some time I can assume body is rotating like this. Are you able to understand, ma? Actually, definitely it is moving on a rod, but I will assume temporarily this I will consider to be my axis of rotation. If you consider this one to be the temporary axis of rotation, then body is not undergoing a translational motion, it is rotating about this point. Are you able to understand? Then in that condition, the kinetic energy of, or you can say total kinetic energy, I can call it as half I axis multiplied by omega square. So this is the equation for total kinetic energy. In which condition? Where I take this point to be my axis of rotation. Okay, and total kinetic energy here I have written in which manner? Kinetic energy because of translation plus kinetic energy because of rotation. This one, is it correct, or this one, is it correct? Edi correct in the loop? Both are correct. Clear, nama? Here you are taking a translation motion individually and rotational motion individually. But here what I am doing, I am taking this point to be my temporary axis of rotation. Are you able to understand, ma? And moment of inertia I have to take about which point? Here I have taken moment of inertia about center of mass, no? Okay, ma? Here I have taken moment of inertia about which point? About that point which is in contact with the ground. Ground to tire contact lo untundi kada. About that point I have taken moment of inertia. And this is again equal to kinetic energy because of rotation plus kinetic energy because of translation. Again same concept. Clear, no? So again kinetic energy of due to translation is half I center of mass into omega square plus half m v center of mass square. Both are correct. Are you able to understand? So you can take this one to be your axis and you can use this relation. Then you will get total kinetic energy. But if we want individually the kinetic energies, then you can take kinetic energy because of rotation separately, kinetic energy because of translation separately. Clear? That's it. Make it out. Kinetic energy of disk of mass 10 kg of radius 1 meter, center of mass moving with a velocity of 10 meter per second, and the disk is rolling. Disk is rolling disk. Okay, so let us. So therefore, consider this is the disk whose velocity of center of mass is how much? Velocity of center of mass is 10 meters per second. And what is the radius of the disk? 1 meter. And it is rolling with a particular angular velocity which is not given. Okay, so first of all, kinetic energy I will try to calculate in both the methods. We studied two methods of calculating kinetic energy, we will try to use both of them. Okay, so method number one. So total kinetic energy, how can I calculate? It is half I axis multiplied by omega square. In this method I can calculate, what is I axis? This point I can consider body is rotating about this axis. So this is IOR. What is IOR? Instantaneous axis of rotation. I will consider body is rotating about this axis and I will try to calculate its total kinetic energy. Okay, omega value, is it given? No, therefore how can I calculate? If omega is not given, how can I calculate? Chapandi. What is the angular velocity of this disk? Come on. Sima, V velocity of center of mass, I can call it as omega into r, velocity of center of mass I can call it as omega into r, or V tangential is equals to omega into r. This formula we know. Are you able to understand? Now, now if you take this point to be my axis of rotation, body is rotating about this axis. Now from the axis of rotation, if I start moving away from the axis, V tangential also increases, already మనం చదువుకున్నాం కదా, గుర్తుందా? Clear, ma? We have taken one body, clear, which is rotating about any axis of rotation. This is the axis of rotation. Okay. Then we have taken 2 points or 3 points, point number 1 and point number 2. After some time, these points they reach up to here, point number 1, point number 2. Okay. This point covers less distance, point number 2 covers greater distance. It means whose tangential speed is greater? Tangential speed of point number 2 should be greater, no? Because it should cover greater distance. It means if I move away from the axis nunchi baytiki velle koddi, tangential speed continuously increases. That's what we have studied, no? Same point apply here also. So V tangential, this is the axis of rotation, no? So disk is rotating about this axis. Are you able to understand, no? So if I start moving away from the axis, tangential speed should continuously increasing, no? But total disk have same angular velocity, no? If you take point number 1 and point number 2, they will cover same angle in same time, no? So angular velocity of point number 1, angular velocity of point number 2 is same. So it means for total disk, omega value remains same. Are you able to understand, no? So therefore, if I take this, if I want to calculate a tangential speed of this point, that is nothing but velocity of center of mass also, no? Are you able to understand, ma? So V tangential is equals to omega into R is equals to velocity of center of mass. Okay. Therefore, what is omega value? V center of mass divided by R. Vinal. What is the velocity of center of mass? 10. And what is this distance, ma? From the axis, what is this distance? This distance is nothing but radius 1 meter. So substitute 1 meter here. So 10 by 1 is how much? 10 by 1 is how much, ma? It is 10 radians per second. So this is the angular velocity of this disk. Understood now how I calculated angular velocity? So this total disk is rotating with how much angular velocity, ma? With an angular velocity of 10 radians per second. Is it clear how I have calculated? What about the tangential speed of this point? This point will have different tangential speed, but angular velocity remains same because every point will cover same angle and same time. Omega same untundi prati point. Tangential speed will not be constant. Already we discussed similarities and dissimilarities, no? Based on that concept, we are doing this calculation. Is it clear, ma? Okay, now see. So therefore, omega value I have calculated, which is 10 radians per second. Now what about I-axis? What is the moment of inertia of this disk about this axis? For example, if this is the disk, this is the center of mass of disk, no, ma? I center of mass is how much? Half mr. But this already we know, no? For a disk moment of inertia, half mr square. But I want about this axis, no? Okay. So axis will be like this. This axis also will be like this. So these two axes, are they parallel or are they perpendicular? Parallel. Therefore use parallel axis theorem. Gurtunna ivanni? Parallel axis theorem. What is parallel axis theorem? I is equals to, this is I, or you can call it as I axis. I axis is equals to I center of mass plus md square. This is parallel axis theorem, no? Okay. What is I center of mass? For a disk, what is I center of mass? Half mr square. So half mr square plus m into, what is this distance? This distance is d, no? Distance between two axes. D is nothing but r here. So mr square. So total how much, ma? 3 by 2 mr square. So this is I axis of the disk. Are you able to understand, ma, how we are calculating? So therefore calculate the total kinetic energy. Total kinetic energy formula is how much? Half I axis into omega square. So half of, what is I axis? So 3 by 2 mr square multiplied by omega. What is the omega? Omega value is 10. So 10 square. Clear now? So half into 3 by 2 into, what is the Ri here also? I will write omega only. Okay, ma? 3 by 2. What is the mass of the body, ma? Mass of the body is 10 kg. Radius is 1 meter. Angular velocity is 10 square, which is 100. Okay, so if you do this total calculation, 25 into 3 into 10. So how much, ma? 750 joules is the total kinetic energy. That's all, no? So this is by using which method, ma? By taking this point to be my axis of rotation. If I consider this total disk is rotating around this point. Are you able to understand? instantaneous axis of rotation I have taken, and total kinetic energy is, it is having only rotational energy, if I consider like this, and rotational kinetic energy formula is half I axis into omega square. I axis how I have calculated by using parallel axis theorem, and I have done the calculation. Okay. Now let us try to do in second method, and let us check whether I will get the same answer or not. Clear? Okay. So we are doing in second method. What is second method? Considering translational energy separately, rotational kinetic energy separately. Clear now? It means now which is my axis of rotation? This is my axis of rotation. Okay. Body is rotating about this axis and it is moving also. Previously we have taken this to be the axis of rotation. No? That is the difference. So kinetic energy of because of translation half mv center of mass square, kinetic energy of due to rotation half I center of mass into omega square. Now disk is rotating about center of mass, no? So I center of mass into omega square. Understood now? So write down half into mass of the body 10 kg, no? 10. Velocity of center of mass is 10. So 10 square. Clear now? Plus half I center of mass. So moment of inertia about center of mass is half mr square. So half into mass of the body is 10, radius is 1 square. So total how much? 5. So 5 kg meter square. So I center of mass is 5, omega value is 10 square. So how much? 500 plus 250. 500 plus 250 is how much? 750 joules of energy. Okay. So in this method also I got the same energy, no? Are you able to understand? So like this you can do. So you can take this point to be temporary axis of rotation and calculate half I axis into omega square. So in that condition body has only rotational energy. Okay, ma? But if you take general condition where body is moving also, it is rotating also, and this is the axis of rotation, then you have to take translational energy separately, rotational energy separately. But whatever it may be, always you get the same answer. Okay. And what is this 500 ma? 500 is kinetic energy because of moving in a straight line, translational motion. Rotational energy means this is the energy because of rotational motion. Okay, that's it. Now see ma, here let us discuss the work done in the case of rotational motion. Clear? See here, first of all we will try to understand translational motion, then analogously we will try to derive rotational motion. See ma. So on a body, if a force is applied on a frictionless surface, then how much acceleration will be produced? A is equals to F by M. Clear now? Because of this acceleration, body will start movement. So it will move by a distance of S. So what is the work done in translational motion? Force into displacement. We know, no? We know this relation, no? W is equal to F into S. Clear now? So or you can write F into S2 minus S1 also. What is S2? Final displacement. S1 is initial displacement or initial position. Okay. So S2 minus S1 will give again S, the final displacement of the body. Same concept if I try to study in rotational motion. Now see ma, this is a body which is rotating and I am applying a force on this body, tangential force. So this tangential force will make the body to accelerate. Angular acceleration will be produced. Here what acceleration is produced? Linear acceleration is produced. Here angular acceleration will be produced. So if I multiply this force with this perpendicular distance r, then it becomes a torque. Torque is equal to R into F. Are you able to understand? So we know that torque is equals to I into alpha, which is analogous equation of F is equals to M into E. This is the analogous equation of this one, no? Torque is equal to I into alpha. Already we studied all these calculations, no? Therefore, what is alpha value? Alpha value is equal to torque divided by moment of inertia. Again, these two, they are analogous. Clear, no? A is equal to F by M. A means acceleration, alpha means angular acceleration. Force produces acceleration, here torque produces acceleration. Mass is the measure of moment of inertia. Here I have mass is the measure of linear inertia and I is the measure of moment of inertia. They are analogous equations, no? Okay, now see. So therefore, here what is the equation of work done? Force into displacement. Same equation of work done in rotational motion, how can I write instead of force? Instead of force, torque. That's all. No? Torque and force, they are analogous. No? Instead of displacement, చెప్పండి, displacement. Angular displacement is given by theta. That's all. No? So here, by applying some force, body will move in a distance of s. Here, when you apply force, body starts rotation. It will cover a small angle of theta. Are you able to understand? So here displacement, here angular displacement. So this is the equation of work done in the case of rotational motion. Just by analogy, we are trying to remember. Analogy gurtunte chalu, equation also you can remember. Are you able to understand? Ma? Or instead of writing in this method, if I want to write in this method, how can I write? Work done in rotational motion is equals to torque into theta 2 minus theta 1. So this is the equation of work done. Are you able to understand? No? Similarly, I can write equation of power also. No? Power is equals to, I can write force into velocity. This is the equation of power, no, in translational motion. Same equation of power in rotational motion, how can I write? Power is equals to torque. Instead of velocity, angular velocity. So power is equals to torque into angular velocity. So you can write like this also. Are you able to understand? That's it. Make a note of this one. Theorem in rotational motion. So in translational motion also we studied same equation. No? Work done is equal to change in kinetic energy of the body. And we have done many calculations also. No? Work done is equal to change in kinetic energy. Clear, no? And how many types of work can be done? How many types of work can be done, ma? Work can be done by conservative forces, work can be done by non-conservative forces, work can be done by pseudo forces, work can be done by other external forces. Total is equal to change in kinetic energy. Okay? We have done many questions on this one now. And in rotational motion, just we will get an additional kinetic energy, rotational kinetic energy also we will get. If body has a translational, it will get a change in translational energy. If body has rotational energy, there will be change in rotational energy also. Okay? So delta K represents what here? Delta K represents change in both translational as well as rotational energies. Are you able to understand, ma? Translational energy is also changing, rotational energy is also changing. Clear, no? So then we have studied work potential energy theorem also. No? What is work potential energy theorem? Work done is equals to, work done by conservative forces is equals to negative of change in potential energy. Do you remember this one? If conservative forces will do positive work, then potential energy of the body decreases. We studied now already. If conservative forces does negative work, then potential energy of the body increases. Work energy theorem lo chadukunnam kada idi, same concept we are using here also. Okay? So therefore, if I write, if only conservative forces are acting, if only conservative forces are acting. Are you able to understand? If only conservative forces are acting, then this force is not there, this force is not there, this force also it is not present. So only which force is present, ma? Only conservative forces, if they are present, then this is equal to change in kinetic energy. Now instead of conservative forces, what I can write? Minus delta U. So minus delta U is equals to delta K. Therefore I can write delta U plus delta K is equal to 0. What is the meaning of this one? If only conservative forces are acting, change in kinetic energy plus change in potential energy is 0. It means finally kinetic energy also will not change, potential energy also will not change. In which condition? If only conservative forces are acting. Are you able to understand, ma? So, or you can say the sum of kinetic energy, potential energy will change, ma. But sum of changes will be how much? Sum of changes will be 0. So therefore what we say, total change in mechanical energy is 0. Sum of kinetic energy plus potential energy is called what? Mechanical energy. So total change in mechanical energy is not there. It means mechanical energy remains constant. Clear now? So this equation also I can write u2 minus u1 plus delta k, I can write k2 minus k1, total is equal to 0. Clear now? So therefore I can write k1 plus u1 is equals to k2 plus u2. What is the meaning of this one? This is total initial mechanical energy. And what is this one? This is final mechanical energy. Understood? No? It means mechanical energy change doesn't happen. In which condition? If only conservative forces are active. Same equations we derived in work power energy also. Here also same equations. But what is the difference between in that chapter and in this chapter? Here I have change in kinetic energy. No? Here I will get additionally change in rotational energy also. Akkada linear kinetic energy matram chadukuntam kada. Here I will get in additionally rotational kinetic energy also. That's it. Remaining everything is same. Okay, ma? So therefore, total change in mechanical energy is 0. It means initial mechanical energy and final mechanical energy, they are equal. In which condition? If only conservative forces are active. That's it. And what are the conservative forces? Gravitational force is a conservative force. Electrostatic force is a conservative force. Spring force is a conservative force. Remaining many of the forces, they are non-conservative forces. Friction, non-conservative force. Are you able to understand? Like a disc-shaped pulley, a wire is surrounded to this pulley, and other end of the rope is connected to a mass of 4 kg. That is the given data. Now when I release this system, initial angular velocity is 0. I am releasing this system, and weight of this 4 kg body will pull this 4 kg number downwards. So disc starts unrolling. It starts unrolling the what you call that rope. Clear now? So mass given, radius given, find the angular velocity of the disc after 10 seconds. It means this body, after it falls through a distance of 10 seconds, time of 10 seconds, then at that instant what will be the angular velocity of the disc? Okay, let us see. See here, let us write the free body diagram of 4 kg body. If I draw the free body diagram of 4 kg body, on 4 kg body how many forces are acting? Its own weight 40 Newton will be acting in downwards direction, and tension T will be acting in upward direction. Here in the rope tension T will be there, no? So tension will be always in which direction? Away from the tied end. Okay. But body will accelerate in downwards direction, no? So therefore which force is greater than which force? 40 is greater than tension. So I can write 40 minus T is equal to mass into acceleration. So 40 minus T is mass of the body is 4. Acceleration I don't know, so let it be my first equation. Understood now? Now same tension will be pulling this rope in downwards direction. Already we studied tension is always equal and opposite. Tension is always equal and opposite in a massless string. If you take mass also to a string, then it is a different condition. But we are not taking mass of the mass of the rope or string we are not taking. Okay. Now what this tension will do? This tension tries to pull the rope downwards, no? It means it is trying to accelerate the pulley. It is trying to give angular acceleration to the pulley. Okay, ma? Therefore, torque will be produced. No? Torque formula, R into F is equals to I into alpha. This is the equation of torque, no? Clear now? So therefore, radius is how much? Force is applied at what radius, ma? Tension ante force hai kada. Force is applied at what distance? At a distance of R is equal to 1 meter. So 1 meter multiplied by force applied is nothing but tension. So moment of inertia of a disc is how much? Half mr square multiplied by alpha. That's all. So therefore tension is equals to half. Mass of the disc is 10. Radius of the disc is 1. Alpha value I don't know. So T is equals to 5 alpha. This is the relation which I got. T is equal to 5 alpha. Now what is A and what is alpha? See the unknown quantities. 1, 2, 3 unknown quantities. But how many equations? 2 equations. It means I require one more equation. Third equation ekkadi nunchi vastund cheppandi. Already we studied this kind of model previously. Third equation, from where can I get? Constraint motion. Okay. Sima, this is the pulley, no? Okay, acceleration of the mass is how much? Acceleration of the mass is A. Acceleration of the rope is how much? Acceleration of the rope is also A. Tangential acceleration of the pulley is how much? That is also A. Because same rope is connected with the pulley. No? Pulley speed acceleration ఎంత ఉంటుందో rope acceleration కూడా అంతే ఉంటుంది. So ropes pulley's tangential acceleration is A itself. Okay. And what is the equation of tangential acceleration? R into alpha. So this is my third equation. Equation number 3. This is my equation number 2. Clear number? From both of them, I am supposed to find out A value. Because I don't know our omega value, can I calculate it directly? Okay, let us see. Clear number? So therefore, what I will do, take this alpha and substitute here. Instead of alpha, I can write A by R number. Instead of alpha, I can write A by R. So substitute here. So therefore, tension is equals to 5 into A by R. Okay. So 5 into A divided by radius is how much? 1 meter. So 5 into A. Are you able to understand? Ma? Now solve these two equations. So 40 minus T. So this one I am substituting here, but don't be confused. Clear? So 40 minus T is equal to 4A, and I got tension is equals to 4A. So 40 minus tension is 5A is equal to 4A. So therefore 9A is equals to 40. So A is equals to 40 by 9 meters per second square. So acceleration I have calculated. Are you able to understand? So acceleration of this body I have calculated. Same is the acceleration of rope also. Same is the tangential acceleration of pulley also. After how much time? Not how much time. The acceleration produced is this much. 40 by 9 is the acceleration. Are you able to understand? Okay. So therefore, now see. Now take the free body diagram of this. No need of free body diagram. No. Just I can use the relation S is equals to ut plus half at square. So distance after 10 seconds he gave no. So let us take a final velocity. I will take V is equals to u plus at. So final velocity of the body is equals to initial velocity is 0, acceleration is 40 by 9, and time taken is how much more? Time taken is 10 seconds. So 40 by 9 meters per second. So this is the velocity of this mass. Vinandi carefully. First listen very carefully, then we can understand. Okay, ma? So what is the velocity of 4 kg body after 10 seconds? It has an acceleration of 40 by 9, no? So we are calculating final velocity. After 4 seconds, what will be the final velocity? V is equal to u plus at, 400 by 9 meters per second. Again we use the constraint relation. See here. Acceleration of the mass is, velocity of the mass is how much? 400 by 9. Clear, no? Velocity of the rope will be how much? 400 by 9. Clear, no? Tangential velocity of pulley will be how much? 400 by 9 meters per second. Rope ki anta velocity untundo, pulley kuda ante tangential velocity untundi. Is it clear? Once I calculate a tangential velocity of the pulley, it is equal to omega into r, no? Tangential velocity formula, omega into r. So therefore V tangential, what I want omega, no? So V tangential is equal to omega into r. So omega value is V tangential divided by r. V tangential is how much? 400 divided by 9. Radius is 1. So omega is equals to 400 by 9 radians per second. That's all. That is my answer. Okay, ma? So this one I have done by which method? General method of solving. Okay. I have not used law of conservation of energy, no? So first of all do in this method, then we will study how to solve by using law of conservation of energy. అర్థమైందా ఎలా చేసుకుంటూ వెళ్దాము ప్రాసెస్? క్లియర్ నమ్మా? సో ఫస్ట్ ఈక్వేషన్ బై యూజింగ్ న్యూటన్స్ లాస్, సెకండ్ ఈక్వేషన్ బై యూజింగ్ టార్క్ ఈక్వేషన్. సో బట్ ఆల్ఫా ఐ డోంట్ నో, ఐ హ్యావ్ యూజ్డ్ కన్స్ట్రెంట్ రిలేషన్, and by solving all of that I got A, acceleration. Once I get acceleration, I can calculate final velocity of the block. Final velocity of the block is nothing but tangential velocity of the pulley. Once I know tangential velocity, I can calculate omega. So this is the process in which I have proceeded in the problem. Okay, that's it. So while practicing, try to calculate like this one. When you don't understand, you should ask the teacher. Batti kottakudu deni kuda. Clear? Law of conservation of energy. Law of conservation of energy. Are you able to understand now? Sir. So here on this system, external forces, are they present or not? Leave. Gravitational force on the other. Gravitational force is pulling 4 kg body downwards. So gravitational force is present. So gravitational force is what kind of force? Conservative force. Any other forces? Tension is there, but tension is an internal force. Tension kuda force hai kada, kani tension a type of force? Internal force. Bite nunchi em act avatam ledhu kada, it is internal force. You need not consider that. And work done by tension is always zero. Already we have studied. Work done by total tension will be zero. So therefore, only gravitational force is acting. So I can use law of conservation of mechanical energy. I can use this one. Law of conservation of mechanical energy. Okay. So what is law of conservation of mechanical energy? K1 plus U1 is equals to K2 plus U2. This is law of conservation of mechanical energy. No? Okay. So what is K1? Initial kinetic energy. It means when I release this system, immediately there are no kinetic energies. No? This body is also in rest position, disk is also in rest position. So total initial kinetic energy is 0. Understood now? Then potential energy. Let us take this position to be initial potential energy. This position to be initial potential energy. Or you can take this reference to be zero potential energy reference. Are you able to understand? Position of the disk will never change. No, disk will be present at the same position. But at this mass, it starts continuously moving downwards. Are you able to understand? So, zero potential energy, this reference I am taking. So, initial potential energy is how much? Initial potential energy is 0. Because the initial position itself I have taken to be my reference of zero potential energy. Already we studied, no? Potential energy you can never define without a reference. Reference lekunda potential energy ni manamu define cheyalem. Okay? So this is the reference. And at that position potential energy is 0. Okay? Final kinetic energy. So let us write here. Okay? So K2. K2 means what? Final kinetic energy. Now see. When this body, when it reaches up to a distance, this mass will have some velocity. Similarly, this disk also will have some velocity, angular velocity. Okay? So total kinetic energy is kinetic energy because of mass plus kinetic energy because of disk. Rendu kinetic energies kuda untayi kada. Mass will have which type of kinetic energy? Mass ki a type of kinetic energy untundi? Translational or rotational? Translational kinetic energy. And what is the formula for translational kinetic energy? VCM square. Okay. And disk will have which kind of energy? Rotational energy. What is the formula for rotational energy? Half I center of mass into omega square. These are the two energies. Are you able to understand? And final potential energy. So let us consider this mass, it reaches somewhere up to here. Okay, mass reaches somewhere up to here. So it has come downwards by a height of h. That's all, no? This mass koncham kindiki vastundi kada, 4 kg body. And what is the height reached by the body? I don't know. So let us assume that height to be h. Understood, no? So therefore, final potential energy will be how much? Minus mgh. Very good. Why minus mgh? It has reached a negative distance, no? So zero potential energy reference is there. Above that reference, potential energy is positive. Below that reference, potential energy will be negative. So minus mgh. Clear, no? Now substitute in the total equation. So K1 plus U1 is equals to K2 plus U2. Initial kinetic energy is 0, initial potential energy is 0. Final kinetic energy is half mv square plus half I center of mass into omega square minus mgh. That's all, no? Okay. So from this total calculation, what I require? I require omega value, no? Are you able to understand, ma? Now see. So here, what is meant by V? V means what? V means velocity of the mass, final velocity of the mass. Velocity of the mass equal to velocity of rope, no? Velocity of rope equal to tangential velocity of the disk also, no? Again by using constraint relation. Are you able to understand? So V means velocity of mass, velocity of rope, velocity of disk also. Clear, no? I already chadukuna constraint motion. And V tangential formula omega into R. So instead of V, what I can write? Omega into R. So write down. So 0 is equals to half into m into, instead of V I can write omega into R whole square plus half I center of mass into omega square minus mgh. So I got equation up to here. Okay ma? So I require omega. Omega ganagado nak kavalsindi. So m I know, R I know, I center of mass I know, everything I know. But h value I don't. H value I don't. What is the height reached by the body? Do I know that? I don't know. So first of all I have to calculate h value. So how can I calculate h value? Okay ma? So already in the previous condition I calculated acceleration, no? Are you able to understand ma? So can't I calculate s is equal to ut plus half at square? Okay. So h is equals to 0 plus half. What is the acceleration in the previous condition ma? 40 by 9 into time is how much? 10 square. Clear no? So therefore how much ma? Half into, I can write 20 by 9 multiplied by 100. Clear no ma? So 2000 divided by 9. So this is the height reached by the particle. Okay. So take this height and substitute here, then omega is the only unknown quantity, no? Calculate omega, that is my required answer. Is it clear? That's it. So therefore substituting here, what I will get? So 0 is equals to half into m into omega square r square plus half I center of mass into omega square minus mg into h. H value is 200. Or let us substitute all the values, no? All the values we don't know, let us substitute all the values. So 0 is equals to half. So mass of the mass is how much? 4 kg. And omega value I don't know. Omega square radius. Radius is how much? Radius is 1 square. Okay ma? Plus half. What is the moment of inertia of a disc? Half mr square. So half into mass of the disc is 10 kg. Radius of the disc is 1 square multiplied by omega square. Okay ma? So minus again mgh. M means mass of the mass, no? 4 kg. G value is 10. Height is how much? Height is 2000 divided by 9. Omega is the only unknown quantity, no ma? So calculate omega, that is my required answer. Like this also I can do. Understood now how we are calculating? Okay. So previously we have used the general method. Now this is the method of force method, previous method. This method by using law of conservation of energy. So understood now, say here. So here I will get 4 2s are 8 now, 8 2s are 16. So this side also I have multiplied by 2. Okay. And here if I take omega square common, then it is 5 plus 4 9, no? Again 9 if it comes to this side, 9 9s are 81. So root of 1,60,000 divided by 81 is nothing but, so 16 root is 4, root of 10,000 is 100. So 40 divided by root 81 is 9, 40 by 9. That's it. Okay. So this is the second method of doing the calculation. The first method we have calculated by using force method, and this method by using energy method. Okay. So this is the question. So this wheel has a moment of inertia of I ma, radius is r. Okay, this is a mass which is attached to one end of this rope. Now when I release this system, this mass, when it falls by a distance of h, okay, then we are supposed to find out, well, what will be the speed of this block. Clear now? When it has fallen by a distance of h, what will be the speed of the block that I want to calculate. Okay. So can you say how can I do this calculation now? Law of conservation of which energy? Energy or mechanical energy? Law of conservation of mechanical energy I can use here. How can you say? See, this mass is being attracted by earth, no? So here gravitational force is acting, and spring will elongate, no? When mass falls down by a distance of h. Clear, no? When it falls by a distance of h, spring also elongates by a distance of h only. So x value will be equal to h. Elongation in the spring also will be h only, no? And spring will develop a restoring force. Are you able to understand? So because of restoring force, some potential energy will be developed in the spring. So spring force is also what kind of force? Conservative force or not? Spring force also definitely conservative force only. Are you able to understand? So only conservative forces are acting, no? So gravitational force is a conservative force. Clear now? Spring force is also a conservative force. So if only conservative forces are acting, then what I can do? Then I can use law of conservation of mechanical energy, which says that K1 plus U1 is equals to K2 plus U2. So this is the equation now. Okay. Now let us do the calculation. So what is K1? Initial kinetic energy. Before this mass is released, so this pulley also does not have any kinetic energy, mass also does not have any kinetic energy immediately when I release the system. So initial kinetic energy is how much? K1 is equal to 0. Clear now? Similarly, let us take this reference. This reference to be 0 potential energy reference. Clear now? Initial position of the mass only I am taking as 0 potential energy reference. So therefore, initial potential energy is how much? U1 is also 0, because potential energy always depends on reference number. So this is the reference which I am taking. So definitely initial potential energy is also 0. So K2, what is K2? Final kinetic energy. Now can you say how much will be the final kinetic energy? Suppose half mv square. For which body? For this mass. When this mass reaches a distance of h, it will be having a velocity of v. Clear no? So therefore its kinetic energy will be half mv square. Completed. This pulley also will be rotating, no? Pulley also will be rotating, no? So if it is rotating, it will have what kind of energy? Rotational energy. So what is the formula for rotational energy? So by the time it reaches a height of h, let us consider it has an angular velocity of omega. Are you able to understand? This has an angular velocity of omega. So therefore I will write half I omega square. So this is final kinetic energy. Okay. What about final potential energy U2? Minus mgh. For which body? For the mass. So this has fallen by height of h normal. So it has covered negative distance. So potential energy also will be negative. So therefore minus mgh. Still. What about this pulley? What about pulley? Hello? So what about the potential energy of this pulley? Pulley, you cannot consider its potential energy because its initial position and final position is same. You need not consider. But what about the potential energy of the spring? Spring will elongate, no? When this mass, when it falls down by distance of h, spring also elongates by how much length? H length only. What is the formula to calculate potential energy stored in a spring? Half k x square. So plus half k, instead of x I will write h square. That's all. No? So potential energy is stored in a spring. This is the formula, no? Half k h square. So therefore all the parameters we have calculated, no? Just substitute in this equation k1 plus u1 is equals to k2 plus u2. Then calculate what he is asking. Calculate this velocity of the block. V value you calculate, that is my answer. Okay. But omega value, is it known? Do you know omega value? No. Then how can you? Omega value I don't know, no? Torque. టార్క్ ఎంతో తెలియదు నాకు, ఫోర్స్ ఎంతో తెలియదు. తర్వాత we don't know tension also, no? We don't know time also. We don't know anything. So how can I calculate omega value? This is the only unknown quantity which we need to find out. Omega value, how can I calculate? Constraint relations are there, no? What is meant by constraint relations? Sima. If this mass has a velocity of v, this rope also will have how much velocity? Rope also will have a velocity of rope is equal to v. What is the tangential velocity of the pulley? Tangential velocity of the pulley is also v. That's all. Yesterday only we studied, no? Mass is having a velocity of v. Then rope also will have same velocity. Pulley also will have same tangential velocity or tangential speed. So therefore Vt is equals to v is equals to omega into Vt is equals to V is equals to omega into R. This is the formula for tangential speed now. Okay. From this, can't you find out omega value? What is omega? V divided by R. So take this omega and substitute here. Okay. Now do the calculation. So find out V value. Finally see what is the answer you will get. So K1 plus U1 is equals to K2 plus U2. Initial kinetic energy 0. Initial potential energy 0. Final kinetic energy is how much? It is half mv square plus half I omega square plus final potential energy is minus mgh plus half k h square. Clear now? Now substitute all the values and find out V tangential or V value, that is my answer. Okay, ma? Instead of omega square, what can you write? I can write V by R whole square. Okay? That's it. Okay, ma? So this is the final answer which you should get. So root 2mgh minus kh square divided by m into 1 plus I by mr square. Okay? Check whether you get this answer or not. That's it. That's it. Okay. See ma, here these are two discs. This is one disc, this is another disc. So this is the common axis through which this disc can rotate, and these discs, they are welded together. Okay, but it means this is one bigger disc and this is one smaller disc. Are you able to understand? And this is the axis of rotation. Around this axis, this disc, they are rotating. So radius of one disc is 2r and radius of another disc is r. Clear? Mass of this one is 2m and mass of smaller disc is m. This is the given condition. Next, on the smaller disc, we are winding some wire. Some wire is wound and other end of the wire is connected to a mass of m0. Are you able to understand? And this total system, it is released from a height of h from the ground. So first question is, what is the total moment of inertia of this system? Second question is, by the time this m0 touches this ground, what will be its velocity? What will be the velocity of the mass m0? Understood now? Okay. Okay, let us do this problem. So can you say what is the total moment of inertia of this system? Moment of inertia of total system will be how much? Chappandi. Moment of inertia of total system will be moment of inertia of first disk plus moment of inertia of second disk. Are you able to understand? So moment of inertia of first disk plus moment of inertia of second disk. Okay. This mass is also there, no? Mass is not rotating. So only this is the total moment of inertia, I1 plus I2. Mass kuda undi kada ikkada. The system is moment of inertia of first disk plus moment of inertia of second disk. Clear now? So what is the moment of inertia of first disk, bigger disk? Moment of inertia formula chappandi disk ki. Half mr square. Half into mass of bigger disk is 2m and its radius is 2r no, so 2r whole square. Clear? Plus mass of the smaller disk, half into mass is m, radius is r square, half mr square. So do this total calculation, half into 2m into 4r square plus half into m into r square. So half into 8 mr square plus half into mr square. Clear now? Half if I take common, then it is 8 mr square plus mr square, 9 mr square. So total how much it is? It is equals to 9 by 2 mr square. That's all. No? So this is the total moment of inertia of this system, 9 by 2 mr square. Understood now? Okay. Now what I am doing is, now I am releasing this system. If I release this system, see this mass m0, it is suspended like this. No? This is how this mass m0 is suspended now. Wire is wound around this smaller disk and it is suspended. So if I release this mass, weight of this mass will pull this smaller disk downwards. So smaller disk rotates and smaller disk is welded with the bigger disk. Bigger disk also will rotate. So therefore by the time it touches the ground, with what velocity it will touch? How can I calculate? How many forces are present? Only gravitational force is present, there is no other force. So if only gravitational force is present, what can we do? Law of conservation of mechanical energy. This is what I can use now. So what is law of conservation of mechanical energy? K1 plus U1 is equals to K2 plus U2. That's all. Various forces available. So initial kinetic energy 0 because system was in resting position before releasing. Similarly, let us take this height to be 0 potential energy reference. Okay, ma? So therefore initial potential energy also 0. Now final kinetic energy means what? When this mass is about to touch the ground, so by the time it reaches here, it will have some velocity, no? Okay, ma? Its velocity is v. So therefore final kinetic energy is how much? Half m naught into velocity square, v square. That's all. No? Then what about rotational kinetic energy of this total system? Not only this mass is moving, system is rotating also, no? Disks are rotating also. Then they will have rotational kinetic energy also, no? What is the formula for rotational kinetic energy? Half I into omega square. So this is the total kinetic energy of the system. Clear, no? Then what about potential energy? Potential energy only for this mass. So negative potential energy, no, it has come downwards from the reference. So therefore it is minus m naught into g into h. That's all, no? So from this what he is asking to calculate v value. But do I know omega value? Omega value I don't know. So what can I do? Again constraint relation, same concept. Clear, no? So v tangential is equals to v is equals to omega into r. That's all, no? If velocity of this mass is v, velocity of rope is how much? Velocity of rope is also v. If velocity of rope is how much, tangential speed of the pulley is how much? Tangential speed of pulley is also v. Which pulley? Bigger pulley or smaller pulley? Smaller pulley is a tangential speed is v. Are you able to understand? So therefore v is equals to omega into r. R means smaller or 2r? Smaller only, no? Because rope is attached to smaller disc. So I will write small r. So therefore what is omega value, ma? Omega is equals to v divided by r. Okay. So take this omega value and substitute here. Okay. Then what is the only unknown quantity we have? Only unknown quantity is v. Calculate v value, that is my required answer. That's it. Okay. That's it. So if you do this total calculation, I am writing the answer, ma, what you should get. Check whether you get that answer or not. So v is equals to root of 4 m naught gh divided by 9m plus 2 m naught. That is the final answer which you should get. Okay. Side, ma. So see this question, ma. So this is a vertical rod, ma. Vertical rod means we know, no? Rod is like this and this is the axis of rotation. Clear? So we are slightly pushing this rod and we are releasing. Initially it was in rest position. We are slightly pushing and releasing. Then we are supposed to find out angular velocity as well as linear velocity of one end of the rod by the time it becomes horizontal. If I push this rod, after some time what will happen? It will become horizontal, no? It will fall to the ground. So by the time it is falling to the ground, this particle will have some tangential speed, no? Similarly, total rod will have some angular velocity also. These two values I am supposed to calculate. Can you say how can I do the calculation? Cheppan chesinaru kada any problems. How can I do?
Sir, linear velocity v square minus u square equal to 3s.
This is not straight line motion, or alpha value I don't know. Alpha value, do I know? Alpha value we have to calculate. Okay, ma? One method she is saying by using v square minus u square is equals to 2as. That is omega square minus omega naught square is equals to 2 alpha into theta. Clear, no? But here alpha value I don't know. Are you able to understand? And the torque acting on this rod also it is not a constant. Okay. So by using integration process only, we can definitely calculate in this method, but we have to use calculus. Without calculus, how can I do? So very simple, no? What is the force acting on this rod? Why it is coming downwards? Because gravitational force is pulling the rod. That's all. No? Gravitational force is what kind of force? Conservative force. Are you able to understand, ma? So because only conservative forces are acting, I can use this relation, no? K1 plus U1 is equals to K2 plus U2. Total initial mechanical energy is equal to total final mechanical energy. So when rod is released, what is its initial kinetic energy? 0. It doesn't have any kinetic energy, no? Ma? Now what about potential energy of the rod? Ma? Rod, is it having any potential energy or not? Rod ki potential energy unda leda? Undi. Where? Total mass of the rod will be concentrated at its center, no? Because this is a symmetrical body, no? So for symmetrical bodies, where center of mass will be? At its geometrical center. Understood, no? So center of mass is present at a height of L by 2, half of the length. So therefore, what is its potential energy, initial potential energy? Let us take a ground to be my reference. I am taking this one to be 0 potential energy reference. Okay. So when compared to here, what is the potential energy of the rod? How much? Plus mgh, no? Plus mgh. It is above the reference. Plus mgh. So final kinetic energy. By the time the rod touches the ground, it will have a tangential speed of Vt. Are you able to understand, ma? So therefore, kinetic energy means this rod is only rotating, no, ma? Falling means what? This rod is rotating. Rotating means it will have which type of kinetic energy? Rotational kinetic energy. What is the formula for rotational kinetic energy? Half I into omega square. Okay. And final potential energy. It has reached ground, no? And ground only I am taking my reference of 0 potential energy. So final potential energy is how much? 0. Are you able to understand? So therefore, now do the what he is asking me actually? Angular velocity as well as linear velocity. So mgh is equals to half into, now what is the moment of inertia of this rod? Moment of inertia. Rod is rotating about one axis, no? At one end of the rod, axis is present. When axis is present at one end of the rod, what is its moment of inertia? I is equal to ml square divided by 3. This is the moment of inertia, no? So substitute. So ml square divided by 3. Let us write all of them. They are given in capital letters, no? So ml square by 3 multiplied by omega square. Okay. So calculate omega value from this one. So therefore, mgh is equals to ml squared by 6 multiplied by omega square. So m and m get cancelled. So omega is equals to square root of 6gh divided by L square. So omega is equals to root 6gh divided by L. So this is my omega value. Understood, no? So once I calculate omega value, how can I calculate linear velocity at one end of the rod? Linear velocity at one end means what? What is this one? Tangential speed. What is the formula for tangential speed? V tangential is equals to omega into r. Okay, ma? So V tangential is equals to omega value root 6gh divided by L multiplied by r. R means what? R means distance from this axis, no, ma? So this length is again L. R is equal to L. Okay. So multiplied by L. So L and L get cancelled. So V tangential is equals to root 6gh. That is my answer. Clear? That's it. Okay, ma? So here h value is not given in the data, no? H means what? Height where center of mass is present. This is called h, no? In mgh, h is nothing but L by 2, no, ma? So substitute that value. So h is equals to L by 2. So therefore V tangential is equals to square root of 6g into L by 2. Okay, ma? 6g into L by 2. So Vt is equals to root 3g L. So that is my answer. Okay. So see. So here this is a horizontal table, ma, and there is a friction between small m and this table. and 3m is the mass which is suspended from other end of the rope. Clear now? Then by this time this mass covers a distance of h. Okay, it falls down by a distance of h. Then what is the speed of these blocks that I am supposed to calculate? Clear now? And this pulley is also rotating. Moment of inertia of the pulley is I, its mass is m, its radius is r. Okay, but moment of inertia is given, other quantities are not required, just he gave. Okay, let me see answer he gave in moment of inertia only, so no problem. Okay, so therefore anybody, can you say how can I do this problem? Can I use law of conservation of mechanical energy? This use cheyocha? Law of conservation of mechanical energy I cannot use. Why? Friction is there, no? Friction is not a conservative force. Friction is a non-conservative force. So definitely law of conservation of mechanical energy I cannot use, but I can use law of conservation of energy, no? Okay. What is law of conservation of energy? Work done by conservative forces, work done by non-conservative forces, work done by pseudo forces, clear nama? Plus work done by other forces. Total should be equal to change in kinetic energy. This is called as work energy theorem, no? Or you can call it as law of conservation of energy equation. Okay. So are there any conservative forces? Gravitational force is a conservative force, no? So gravitational force is doing on which body? Work on this body or this body? 3m. Okay. Because this is the only body which is moving downwards, no? So gravitational force can do work only on 3m. So gravitational force, will it do positive work or negative work on this body? Adi kuda chudali. Whether it will do positive work or negative work. This body of mass 3m, when it falls by a height of h, gravitational force, is it doing positive work or negative work? Positive work. Why positive work? Gravitational force will be acting in downwards direction. Displacement is also in the same direction. So angle between them is 0, cos 0 is +1. Understood, Nama? Work done formula, do you remember? W is equal to Fs cos theta. Force is gravitational force. Displacement is in downwards direction. Angle is also 0. So it is plus Fg into S. Positive work. So substitute here. So work done by conservative force is, what is the gravitational force, ma? Gravitational force is nothing but 3 mg, weight of this body. Clear, no? Displacement is how much? H. And angle is 0, cos 0 value is 1. And work done by non-conservative force. Non-conservative force is what here? Friction. So work done by friction, first of all, friction is doing work on which body? This body, this body, or this body? Work is done by friction on this body. Positive work or negative work? Negative work. Friction will do negative work in this condition because the displacement is in this direction, no? But friction always acts in opposite direction. So therefore I will write minus of work done by friction formula, frictional force multiplied by displacement. That's all, no? Work done force into displacement only, no? Which force? Frictional force. Displacement, let it be S. Pseudo forces. We are not taking any accelerated frame, so pseudo frame is pseudo, work done is 0, and work done by other forces is also 0. So this is equal to total change in kinetic energy. Okay. Total change in kinetic energy means I have to write a K2 minus K1 number, final kinetic energy minus initial kinetic energy. Now substitute all the values. So therefore 3 mg into H minus FL. Limiting friction formula? Mu S into N. So mu into N. N means what? Normal reaction. What is the weight of this body? Mg. Normal reaction will be how much? N. N is also equal to mg. Clear now? So mu S into mg multiplied by, what is the displacement of this m? When this falls by h, this also moves by h only, no? Clear? So h is equals to final kinetic energy. Final kinetic energy will be present for how many bodies? This will have a velocity of v, no? This also will have same velocity, no? Because they are connected by same string. And pulley also will be rotating with a particular angular velocity, no? So all the three bodies will have final kinetic energy. Clear, no? So final kinetic energy of 3m, half into 3m into v square. Okay, ma? So by the time it reaches here, let its velocity is v, 3m into v square. This body, by the time it will reach here, no ma? So it will be also have same velocity. Okay. So therefore half into, what is the mass of this body? M. Again velocity is v square. Okay. Similarly, disk also, this body is also rotating, no? And it will be rotating with an angular velocity of omega. So therefore, what is its kinetic energy? Half I omega square. That's all, no? Kinetic energy of 3m, kinetic energy of m, and this is the kinetic energy of its body. This is the kinetic energy of this v, which is rotating. Minus initial kinetic energy, 0. Initially every body is in rest position, no? So every kinetic energy is 0. Clear? So speed only he is asking, no? It means he is asking v value. But omega is also there, no? Again, how can I calculate omega value? Again, how can I calculate? Sima, velocity of this block is v. Velocity of this rope is also v. Tangential speed of pulley is also v only by constraint relations. Okay. So therefore, v tangential is equals to omega into r. So omega is equals to v tangential divided by r. Or just I can write v by r. So substitute this v value there. Now let us do the total calculation. So 3 mgh minus mu into mgh. Okay, ma? So this is equals to half 3m v square plus half m v square plus half I, instead of omega what I can write, v by r whole square minus 0. So calculate v value from this one. That is my required answer. Understood, no ma? So I will give the answer of this, check whether you get the same answer or not. Okay. So final velocity which you should get is square root of gh into 3 minus mu divided by 2 into 1 plus I by 4m r square. Okay, ma? So here he gave us capital R, no, I will write capital R only. 4m into r square. So that is the final velocity which you will get. Is it clear, ma? Okay. Very, very easy, ma. Within 2 minutes, less than 2 minutes, you can do these calculations. But you should be clear about what is happening and what you have to do. Then very easily you can do.